Alright, hello everybody. Today I'm going to be doing a quick tutorial going over all the software side of the CNC machine. I'm going to be going over what in Marlin you need that interests you, which is the firmware that the Arduino uses, as well as go over the different ways of generating the tool path for the CNC machine. So first off, generating a tool path for the CNC machine can be done with two main ways, using CAM software to actually be able to cut out more three-dimensional objects, or using more simpler programs like I'm going to show you how to do today, which just cuts out like two-dimensional shape, similar to like engraving or something. So first off, a CAM is something like Autodesk's Fusion 360's CAM option, which, as you can see, using a three-dimensional shape, it can actually cut out things in a more three-dimensional way. Versus what I'm going to be showing you today, which is Easel by Inventables, which is a free browser-based software, which is more of a 2D approach to it. So to open up Easel by Inventables, you first just type in your browser easel.inventables.com. And you're going to have to create a free account and stuff just because they want to track you or something, I don't know. But once you do that, create a free account, you'll come to a page like this, and you're going to want to say, I want to make a new project. And so once that loads, you'll be greeted with Easel's interface, and on the left-hand side is where you're going to lay out your shape to be cut, and then on the right is a simulated quick tool path of how it's going to actually cut out things. So first off, what you're going to want to do is measure the dimensions of the material you want to cut. And in my case, I want to do a 7-inch by 11.5-inch board that is 3/4 inch thick. And actually, I'm going to switch my Y and my Z, and my X. Do that. And I can see the simulation changes in real time to what you want. Next, you're going to want to choose your bit. In my case, I'm using a 1/4 inch upcut bit. Now, Easel doesn't really care when generating the tool path whether you have an upcut or downcut bit. You can modify it to like run like the right side of the bit on the wall or the left side of the bit on the wall, depending on how you want it to be finished up. But I don't really care too much about that. I haven't really noticed that much of a difference. So anyways, to do a custom bit, other than one of these presets it has, you just type it in here. And in my case, I'm doing a 1/4 inch bit, so I'm going to do 0.25 and then in inches and hit enter. So now I've got my bit set. And then your material, for what Easel's concerned with, this is kind of just an aesthetic thing to generate your preview. It doesn't really matter what you change it to, so I'm just going to leave it as birch plywood. And then you're going to want to go over to cut settings. Now this is this is an important part that you want to change. The feed rate and plunge rate you can leave because we're going to change those later when we actually go in and edit the G-code to make it run with our specific CNC machine. But the depth, as well as kind of the depth per pass. But since I want to only do one pass over my workpiece instead of iteratively plunging deeper and deeper, just because I only really care about one depth of cut for this particular demonstration, I'm going to actually change it to 0.25 inches because I want to do my full depth in one pass. Now, if you're going to cut a different material like MDF or something, or plywood that you want to go slower, you could do this in like 2 or 3 different plunge rates, and then you'll just have to change it later in the G-code to be the actual numbers you want. And so now what we want to do is we want to import what we're actually going to be cutting. Now, Easel can take either an SVG, a G-code, or an image trace. I think that the image trace function is the most useful part of Easel because you can take an image and then it'll upload it and then auto-generate the tool paths based on that. So I'm going to do image trace. And it's going to think a little bit, and you're going to say upload a file. And now I actually have a geometric pattern I just found on Google Images that I'm going to cut out for this demonstration. And so I'm just going to drag my image right onto Easel. It's going to load it, and so that's the kind of shape I want to cut out. And then you're going to hit import. Now, as you can see by looking at the preview, it has already generated a toolpath for my shape. And so that's pretty cool. And then here's the kind of cut settings as well over in this aspect of it. And so what we want to do now is change these pretty much to match our cut settings over there. So the depth I want to go down 0.25 inches. I'm going to hit enter for that. And you can see it's already got the 1/4 inch bit updated into it. And so this depth right here is as deep as you want to go. And then the cut setting over here is how deep per pass you want it to take to get there. And then the shape is kind of where you want home to be. And so for our machine, we want home to be on the bottom left in this kind of orientation, which if we rotate it around, looks like that on our actual machine. Oh, and then by the way, how I'm manipulating this preview, just to click and drag kind of spins it around, holding the scroll wheel or the left click actually drags a piece around, and then the left click just moves it around. All right, so back to the cut settings. Now, there's different ways we can go about generating a toolpath from this image. We can do a fill, or we can do an outline. And an outline has it either you're going to follow the path it makes, as you can see here, which would be doing this. I'll zoom in a little bit more so you can see that. Or you can do the outside of the line, which is going to cut on the outside of where the lines are. Or you can do the inside of the line, which is going to cut like that. In my case, I want to do a fill. I just want to cut out anywhere that it has the picture on it. All right, and so now what I want to do is I want to scale this to how big I want it to be. And in the shape, you can actually type in the dimensions of how big you want it to be, or you can just use your mouse, click and drag to scale it up. And now my piece is 7 inches wide, so I'm going to kind of take this right up to about 7 inches wide, and then I'm going to back it off a little bit to give me a little room to screw it down around the edges of it. And so I'm also going to move it over a little bit as well, just to give me, when I go to screw my piece down to the table, I just want to make sure I have a little bit of a lip there. But since I already know this, and I know that my piece is longer than it's going to be, I'm going to actually just kind of put it back up here, and then I'm just going to, when I screw down my piece, I'm just going to position it, because it's longer than I need it to be, just kind of position it further away. And then also, by the way, down here, there's a dimension changer to switch between inches and millimeters. I'm doing everything in inches, and my machine's set up to inches, so I just kind of left it as it is. So now what we want to do is we want to hit the simulate button over here, and this is going to actually do a simulation of the toolpaths it's going to take to actually cut this shape out. And so now you can see it actually has the red lines indicate where it's going to pick up and move the cut head, and the blue lines indicate where it's going to actually be cutting. And as you can see, it starts off at our origin. It's going to go, I don't remember which way it wants to go. It's probably going to go this way, cut out all this stuff, and then finish back at the origin. And so that's what we want. And then the prediction of how long it takes depends entirely on the feed rates and speed that we're going to set later. So in my case, the time isn't very accurate at all, but you can also play your simulation, and it's going to show you how it's going to actually cut it out, as well as kind of change the speed. So if that interests you at all, that's kind of a cool way to see how it's going to go. And so once you start your cut, if it starts going a different way than how you think it's going to go, then you know something's probably wrong and you can stop it sooner. So now that I got my shape in there and it's ready to cut, and the simulation looks good, it's actually cutting where I want it to. And also, anytime you do a change, you want to hit the simulate button to make sure it's actually going to cut where you want it to. In some cases, when you first drag out your image, it's going to look fine in the simulation, but if you set your bit to be really big, like I'm using a 1/4 inch bit, when you hit the simulate button, sometimes it's not going to actually cut out what I want it to. And I can demonstrate this by making this a lot smaller than it can. Now, if you look at this, it's going to, I might have already updated. So it did, in this case, it already updated, because I already hit the simulate once, but sometimes it doesn't auto-update to actually show what it is. So always make sure you're hitting the simulate button after you change anything to make sure it actually cuts out what you would expect it to. So now that we got that, we're going to go up to Machine, and then Advanced, and then we're going to generate the G-code. This software is made by Inventables, who has their own brand of CNC machine called the Shapeoko. And so for them, they can actually run it directly from this program. But for us, since we have our own custom machine and want to edit the G-code, we're going to hit the Generate G-code button. And then once it generates, we're going to hit the Export G-code button. And as you can see, it's going to download that here as an n.c file. I'm just going to drag it to our desktop here. All right, now that we have that done, we can close this window, and we're going to go now and actually edit the G-code to how we want it to be. And so first, before I do that, I'm going to explain what is actually in the zipped file you're going to download from Thingiverse that contains all the code and stuff. Now I'm probably going to rename the file before I upload it, but inside of there, we're going to find a few different things. We're going to find a version of Marlin, which is the version of the firmware that we're going to flash the Arduino with. And Marlin is the firmware that is written in Arduino, and I can open it here and show you it. You know, it's on the wrong monitor, so I'm going to drag it down here. And so when you open up Marlin, this is they have a very nicely organized tab system. So if you want to really go in detail and really understand this, you can. But for what we're going to do, you really don't need to know all of this. The main tab that we care about for setting up our CNC machine is called the configuration.h tab. And this is where you set up all the parameters of your machine. And so the first thing you notice as you scroll down is when you scroll down past the serial port, we're going to find a define baud rate. Now this is a very, very important part that you need to catch, because if you don't catch this, your machine will flat out not work. Now the baud rate is telling you at what speed or at what frequency, I guess I don't know exactly how it works, but it's essentially what frequency we're going to communicate with the Arduino at. And so when we open our print run prompter face, which is the second folder here, which is how we're actually going to, which is the application that actually controls the machine. When we open that up, you can see right at the top, right here, we have the baud rate. And so our machine is set to 250, I just got to type in it, 250,000. And so we want to make sure that number right there, which 250,000 is actually a good number. I suggest changing to that. We want to make sure that number matches our baud rate that is in our Arduino code. Because if it doesn't work, it's going to try and communicate, and it's just not going to work. So anyways, once you get that set up, the other thing we care about is going down to the movement settings. So we're going to go past all these other settings that we don't really care about. They are nicely labeled, so if you want to find what they are, they all got lots of commas and comments and stuff, so it is very nicely organized. But what we care about is the movement settings. And right down here, we're going to define our default axis steps per unit, our max feed rate, and our max acceleration. Now these values right here for my threaded rod give it so that 1 unit for me is 1 inch. Now that, as you can see, that's a very large increment compared to what it's going to probably by default be set into as 1 unit is 1 millimeter. But for using easel and stuff, it's just a lot easier to think about it as, I want to go by 1, it's going to go by 1 inch instead of 1 millimeter. And then in here, there's other acceleration and stuff. And then also in here, you can also define, you can set software end stops. This kind of turns them on and off. And what that allows you to do is, I don't remember exactly where in here it defines it as, but you can actually set a software end stop to the max build volume of your CNC machine so that it doesn't ever accidentally exceed how big your build plate is and accidentally break something. But I really haven't ever been using the full dimensions of my machine quite yet. I haven't ever needed to make a part that big yet, so it hasn't really been an issue for me, but it is in there if you want to find it. And as well as, if you just go on like Google and stuff, if you don't understand something, you just like go to the Marlin wiki. They have a very large user base for this program. This is what most RepRap 3D printers run off of, and so everything is very well documented, and there's very nice tutorials out there explaining how this works. But anyways, back to what we're doing. Also, before you do this, you need to install your Arduino to one of your COM ports. You've got to first install Arduino software from their website, and then you've got to actually install the drivers for that and link it to a COM port. In my machine, it's actually linked to COM3. I'm actually going to run it off my laptop, not this computer, so it's going to change when I do it there, but I would select COM3 then, and then hit the connect, and it's going to actually connect to your Arduino. But anyways, back to the actual G code. Well, there's 3 main bits of code I'm gonna include with this download. There's a move down to the build plate. There's a reset from the build plate, and then I'm gonna give an example code, which as you can see, I have here. I'm gonna add into there and rename everything. But so the move down to the build plate code is when I say I want to turn my machine off or home it. What I do is actually home it to the y-axis all the way up, all the way to the right, and then the table all the way in. So my home is actually up in this corner. And so what this bit of code is it's going to move it down to the origin, which I set, which is roughly around here. It's actually more in the corner, which is 1 inch away from all of the walls and 1 inch off of the build plate. And so since I'm actually doing that as a safety factor, just because if it ever loses a step or something, then it won't try and run into the wall or something. But so anyways, the first bit of code brings it down to the build plate. And the second bit of code is just the opposite of that. It's going to reset it back up into the corner. If you want to just leave your machine down at the origin by default, then you don't need to care about these code at all. But for me, as I was building it, it was just a lot nicer to return it to the origin up in the corner. But anyways, now what we want to do is we want to take my example code I have and take the code that we generated from easel and combine it into a language that our machine can understand. So if we open this GCode file, as you can see, it's titled .gcode. If we go to properties, you can see it's a GCode file, which is what the Arduino is actually going to be able to read. If we open that with Notepad or WordPad, we can actually see what the code has. Now I'm going to kind of explain. So the way that GCode is laid out with is you have a header, you have your main code, and then you have a footer at the bottom, which is this stuff. So the header essentially initializes your machine, sets all your variables. Then you're going to run your code, which is all it is. All your code is movement commands. Move the X to this location, move the Y to this location, and do it at this rate. And then your end code just kind of resets it after the fact. So I'm now going to kind of explain what all these things mean. If you don't know what something is or want to change something, if you go to Google and just go to GCode